Hello, this is lesson 2 of chapter 8, binomial expansion, and this is all about factorial notation. Well, firstly, what is factorial notation? Well, I'll show you by doing example 3 part A from page 161 of the textbook, which says what is 5 factorial. So the exclamation mark in mathematics means factorial. And to work it out, what you do is start off with that number and multiply it by every successive integer down to 1. And if we do that, we've got 5 times 4 times 3 times 2 times 1, that's 120. You can do this quite quickly in the calculator. Factorial button is here on this Casio, so 5 shift equals 120. So you can do quite quickly using that. What you might be wondering is, what is 0 factorial? And the answer is 1. Now, if you want to know why, you can either Google it or, as I often do, just ask Mrs. Sherwood and she'll tell you why. Now, the reason we're doing this is to work out numbers in Pascal's triangle, because Pascal's triangle is fine for like power 4, power 5, etc. When you get to big powers like power 12, you don't really want to have to do from 1, 1, 1, 2, 1, 1, 3, 3, 1, all the way down to the 12th or 11th row. Thankfully, there's a quicker way of using it, using what's called NCR method. So NCR, it's also written like this, looks a bit like a vector, that is an N and an R. And the definition for that is n factorial divided by r factorial, so n on the top, r on the bottom, nice and easy, and then n minus r factorial. So for example, if we were to do 5 choose 2, 5 with a 2, that's 5 factorial, 2 factorial, and then 5 take away 2 is 3, 3 factorial. So the bottom two numbers will always add up to make the top. Okay, working out, you can do it with a calculator without quite quickly. That's 5 times 4 times 3 times 2 times 1, divided by 2 times 1 times 3 times 2 times 1. You can see we can do some very obvious cancellations here. 3 times 2 times 1, 3 times 2 times 1. We're left with 5 times 4 is 20, divided by 2 is 10. On a calculator, the NCR button on this Casio is down here. So 5 shift divide 2. We can often say it's 5 choose 2, and that's 10. It's a way of choosing the different ways of choosing 2 items from a list of 5. You use it a lot in statistics and probability, which if you go on to do a degree in maths, which I recommend you do because it's amazing, if you do pick any stats modules, you'll learn more about it there. So, back to Pascal's triangle. So say if we wanted to do, I don't know, the 6th row, or power 6 I should say. So we know what the terms are: a to the 6, a to the 5, a to the 4, a to the 3, a to the 2, a to the 1, b squared, b cubed, b4, b5, b6. So know what the terms are. Don't forget the individual powers add up to the overall power in each case. But what about the coefficients? I don't particularly want to do Pascal's triangle 1, 1, 1, 2, 1, 1, 3, 3, 1, all the way down to here. I can use the NCR button. So coefficients are going to be 6 choose 0. Now the common error is for the first term to do 6 choose 1. That's wrong, you have to do 6 choose 0. So remember the first term, 0 on the bottom. 6 choose 1, 2, 3, 4, 5, 6. It's perhaps now a little clearer why you have to start off with 0. So if you don't start off with 0, you can't do the last term. Okay, so we know the first term is always 1. We know the last term is always the same as the power. We have perfect symmetry, so we know those two. What about 6 choose 2? Okay, so that's 6 factorial over 2 factorial, 4 factorial. Now, if you think about the cancellation, 6 times 5 times 4 times 3 times 2 times 1, well, that's going to cancel with that 4 factorial there. So all it is 6 times 5 divided by 2, which is 15. 15, 15. The middle one, I'll just show you how to do on the calculator again. 6 choose 3 equals 20. So it would be a to the 6, 6a to the 5b, 15, a to the 4b squared, and so on. So it's quite handy and quite quick. Example 3 part B was 5 choose 2. So this is example 3 part A. This is example 3 part B. And that is all of the content up to exercise 8B. Actually, there's a part C to example 3. So example 3 part C says the 6th entry in the 10th row of Pascal's triangle. Now if you look at that, it actually does it as 9 choose 5. You might be wondering, well, 10th row, surely it wants power 10. That's because in the textbook, rather annoyingly, it counts the first row as a plus b to the naught, which is just 1. The second row as a plus b to the 1, which is a plus b, 1, 1. So if we want the 10th row, so first row power 0, second row power 1, the 10th row, it's after a plus b to the power 9. And what it wants is the 6th entry. Now, again, the common error here would be to do 9, actually be to do 10 choose 6, but anyway, never mind, it'll be 9 choose 6. But it's wrong, because remember, it's going to be first entry, second entry, third entry, fourth entry, fifth entry. So it actually wants, for the 6th entry in the 10th row, 9 choose 5. So that's going to be 9 factorial over 5 factorial, 4 factorial. Now if you pick up the bigger factorial on the bottom, that's going to be 9 times 8 times 7 times 6 times 5 factorial. That cancels. Divided by 4 factorial. So 3 times 2 is 6, that cancels. 8 divided by 4 is 2. So we've got 9 times 2 times 7. So that's 14 times 9, which is 126, hopefully. Let's check on the calculator. 9 choose 5, 126. Okay, so that's all the content up to exercise 8B, which is here, page 162. So if you can have a go at all of those questions and then let your maths teacher know if any cause problems.